prefer a convex mirror as a rear view mirror in vehicles? Why we are preferring convex mirror as a rear view mirror in vehicles? First of
Because
all, the answer
the
is ha, Shreya. And first,
ma'am, may I answer?
if you want to answer, you first write it on the chat box. Otherwise,
Okay,
I
ma'am.
can't focus on you. Chat box at a time I am opening along with the meet, so I can note it down, so that I can call you. Okay. Um, Shreya. Say the answer, Shreya. Unmute your mic.
Ma'am, because yes, ma'am.
Say.
Ma'am, we use convex mirrors in rear view, mirrors because in it the vehicles from far away l- because when the vehicle is far away it looks smaller, so that so that larger view of the road can be seen from that mirror.
Okay. Uh, it is near to the answer. Two major key points are there. Kartikeya, can you?
Ma'am, we use convex mirror as rear view mirror in vehicles because it gives us a wider view of the object behind. For example, if there is a car
So
behind us, then
that is one
we'll be
part
able.
only.
Yes, ma'am.
But one part, it is a secondary point, and the first point is little different. What is the nature? What is the nature of the image, Kartikeya?
Ma'am, nature of the image, ma'am, virtual, erect.
Virtual and erect. This is the point. Okay, it is an erect image. First point is that only. Okay, 2 points are there. First of all, it is an erect image, and second is it is highly diminished and cover the whole field, wide field of view it covered. These are the 2 points you have to add. And next question is index question on page number 171. Okay, page number 171. One numerical is there. You can note down the question. Find the, if you have the book, you can open the book, page number 171. Find the focal length of a convex mirror whose radius of curvature is 32 meter. Very simple question. What is the relation between focal length and radius of curvature? Focal length equals
Ma'am,
to,
focal length is
radius
half of the
This is
radius
half
of
of
curvature.
radius of
okay.
curve.
If you all will unmute, then it will create problem. Okay, Saurav, your answer is correct. You will try to communicate through chat box. Okay, uh, so it answer is correct, and the concept is focal length is equal to radius of curvature upon 2. Okay, so this is the answer of the question. So the answer may be it is correct. Next is it is again on page number 176. There are some questions which is related to information given in the table that we want to discuss. Next on page number 184, it is also direct calculation part. Now we come to the next one, page number 185 to 86 question. So this is exercise question. Many numericals are there. We will directly goes to the numericals. Okay. So goes to the first numerical. Which one? It will be an object 5 centimeter in length is held 25 centimeter away from a converging lens. Converging lens means which lens?
Convex.
Convex
Convex
lens.
lens.
Of focal length 10 centimeter. Draw the ray diagram. Correct. Draw the ray diagram and find the position, size, nature of the image formed. Okay. So first I will analyze the data, then you can do it yourself. Okay. Calculation part you can do yourself. So let me analyze the question. Object distance, you listen very carefully in between. Until and unless I am not asking, please don't unmute yourself. Okay. First of all, object distance is given. How much it is? 25 centimeter. You know that every time the distance is measured from the lens, from the optic center to the object. So the distance will be negative. So U is minus 25 centimeter. Okay. And next is image distance. We need to find out V. We need to find out focal length is given 10. Since it is a converging lens, focal length will be positive. Very important. So F will be plus 10 centimeter, because it is a converging lens. We will get the image in the other side. So that means the distance is positive from optical center to the image. It is positive. Okay. Now when we substitute these values in the formula, lens formula, what is that? 1 upon V minus 1 upon U is equal to 1 upon F. So when we substitute this value, we will get the answer B. In this way you can find out. Then second, you can find out magnification. From that, we can find out the height of the image. So this is the way you can solve. And the next question is a concave lens of focal length 15 centimeter forms an image 10 centimeter from the lens. How far is the object from the lens? It is also similar question. And ray diagram is important, but here instead of convex lens, concave lens is given. So object distance we need to find out. Image distance is given V is equal to 10 centimeter, but we know that concave lens, the image is erect and virtual.
Virtual.
The distance will be negative. It is on the same side that of object. So the image distance V is equal to minus 10 centimeter. Okay. It is because it is in the left side of concave lens. Focal length, since it is a concave lens, focal length is negative. So the value will be minus 15 centimeter. So this is more than sufficient, and the rest of the part is mathematical calculation that you can do well. Okay. So now I am leaving that also. Diagram also there. There is one diagram related to the question. Next is question number 12. An object is placed at a distance of 10 centimeter from a convex mirror of focal length 15 centimeter. Find the position and nature of the image. So here the simple question is, it is mirror. Okay, so here we are using mirror formula. 1 upon U plus 1 upon V is equal to 1 upon F. Okay, and here object distance is given, that is 10 centimeter, and it is minus negative only because it is left side of the mirror. Image distance we have to calculate the focal length. If it is, since it is a convex mirror, focal length is positive. You know that after the reflection, the reflected radiations are converging, actually meet at a particular point. So we have a focus there, and it is a real focus. So the distance is measured as 15 centimeter. Okay, because it is of convex mirror. Then next is magnification produced by plane mirror is +1. Okay, so that meaning you know how to solve that. Object of 5 centimeter in length is placed at a distance 20 centimeter in front of a convex mirror of radius of curvature 30 centimeter. Okay, so here the question is little different. Here focal length is directly not provided. Instead of that, radius of curvature is provided, and radius of curvature is given as 30 centimeter. From that you can calculate focal length. Focal length is equal to radius of curvature upon 2. So focal length will be plus 15 centimeter. Okay. Rest of the parts are same. Next question, question number 15. It is also similar type. So question number 16. Find the focal length of lens of power -2 diopter. So you know that focal power of the lens is reciprocal of focal length when expressed in meters, and here it is -2 diopter. So -2 is power. So -2 is equal to 1 upon F. So 1 upon F, you will get the answer in meters, and you have to convert that into centimeter. Okay, this is all about that. And next question is also related to that. These are all about the questions related to the chapter light. So now let us think about the next one, human eye. Okay, and the colorful world. So there the first topics were deleted, and it will be starting from refraction through a prism. Okay, refraction through a prism is given. So listen very carefully. So for that we need some previous information. What is the previous information? Wait for 1 minute. Previous information is regarding um, refraction through a glass prism. Okay, refraction through a glass prism is there. When refraction through a glass prism, you maybe A section students, have you completed that refraction through a glass
Yes, ma'am.
rectangular?
Yes,
Yes,
ma'am.
ma'am.
Rectangular. Okay. So when we discuss that topic, you know that there are two refractions takes place. When a light ray coming from air enter into the glass, then it is moving out of the glass. So in this way, two refractions are taking place. So and the first ray is called incident ray, then refracted ray, and after the second refraction, the ray which is coming out, it is known under the name emergent ray. Okay, so there instead of angle of refraction, in the second case, angle of emergence will be there. And there is one significance in the refraction, especially in the rectangular prism. What is the significant? You know that rectangular means what? The sides are parallel to each other, isn't it? The sides are parallel to each other. So the incident ray and the emergent ray, they are parallel to each other. But when we consider a prism, are these two faces of prism are parallel to each other? Have you seen a prism? Have you seen a prism?
Yes,
I'm a
ma'am.
Next class
rectangular
I
or a
will put it.
triangular prism.
Saurav, can you speak louder?
Ma'am, a rectangular or a triangular.
Triangular prism. So
Understand.
prism, normally we are talking about this triangular prism. That's why specifically it is not triangular. That's why we specifically add the word rectangular prism, isn't it? So
Okay.
normally prism means it is a triangular prism. So in a triangular prism, the two faces are not perpendicular to each other. Therefore, the incident ray and the emergent ray, they are not parallel to each other. So this is one difference between refraction through a rectangular prism and refraction through a glass prism. Okay, the diagrams are there in the slide, so I will show you after the discussion. So in the case of prism, the opposite sides are not parallel to one another. That's why refraction through a glass prism, emergent ray is not parallel. Okay, so I will show you, today we'll discuss about the refraction through a prism. Before that, there are some information regarding prism. You know that when a ray of light, white light, you know that white light composed of 7 different colors. Which are the colors? VIJU, isn't it? Color means what? Color means white light composed of 7 different frequencies. You know that wave, particular wave has 5 different characteristic features. Which are the characteristic features of a wave? Which are the characteristic features of a wave? Anyone?
Ma'am, frequency, wavelength, amplitude,
Frequency, wavelength, amplitude,
amplitude, and that. और क्या था? वो
velocity.
Yes.
ma'am, velocity or time period.
Last one.
Time period.
Last one. One more is there.
Time
Wave
period.
number. Wave number. Okay. So these are the 5 different characteristic features of wave. So here 2 significant features are there that we are related to this topic, and they are frequencies and wavelength. Frequency, both are inversely proportional to each other. So there is one formula which is related to these two property, that is frequency is equal to speed of light divided by wavelength. Nu is equal to C upon lambda. So white light composed of 7 different colors means 7 different wavelengths. That means 7 different frequencies. So each frequency, the speed, you see, when light enter into glass prism, so the speed of light is different. Moreover, the speed of different frequencies are different. Okay, because of their difference in speed inside the prism. So the refracted ray, that means the ray which is coming out, which are in the form of a band of 7 different colors. You can see that it is just similar to that of rainbow. The colors are distinct colors are there. Violet, indigo, these all are very distinct colors. But they are not separate. They are fused to each other. Okay, because of this property. Which property? Since they have different frequencies and wavelength, their speed inside the prism is different. Because of that, when white light coming out of the prism, it appears in or it splits into 7 different colors. This phenomenon is known under the name dispersion of light. Okay, dispersion of light, and it is related to rainbow formation. Okay, so now let us move to that particular slide where we can see which are the different important points that we have to take care when light moving from air and passing through the triangular prism and moving out of it. Okay, so this diagram is important because this is in our practical also. Practical and theory, both in both the cases, this is important. That's why let us see the diagram, exact diagram. So for that, now I am sharing my screen. Let us see that, because without the diagram it is incomplete. So that's why first of all I will show you the diagram. Now I am sharing my screen. I think the screen is visible to everyone. So let us see. It is only of 2 minutes duration, but without that it's not good. We want that 2 minutes. So you can see that.
Diffraction of light through a prism. Diffraction is the phenomenon of bending of light rays from optically rarer medium to denser medium. A prism is a triangular transparent optical device. When we shine a beam of light on one face of the prism, the light ray that strikes that face is called incident ray. Let's draw the normal, an imaginary line perpendicular to the face of the prism. The angle between the incident ray and the normal is called the angle of incidence. Inside the prism, the light ray will bend towards the normal at an angle and will continue to strike on the other face of the prism. The light ray then will emerge out of the second face as an emergent ray, bending away from the normal line. The angle between the emergent ray and the normal is called the angle of emergence. The overall reflection of a light ray through a prism is expressed as the angle of deviation theta.
So this you can note. The angle of deviation is the angle between original incident ray and the emergent ray. What do you mean by original incident ray? So you can look at this particular line. Look at this. This is incident ray. Okay. After refraction, deviation of the path. So here refraction takes place at this junction and it deviates to this side. Suppose refraction will not take place, then what will happen? Suppose refraction will not take place. So the incident ray naturally, originally moving to this side. See, you can look at this blue dotted lines. Okay. Similarly, at the second junction where the second refraction takes place and we have an emergent ray, and this emergent ray is moving out of the prism like this. Okay, so when we are retrace it in this way, it met at this particular point, and here there is an angle. Okay, and this angle is known under the name angle of deviation. Okay, so it is the angle of deviation, and it is defined as the angle between original incident ray and the emergent. Original means where the incident ray supposed to move out of the prism. So that is why it is called the original incident ray. And the emergent ray from where it's supposed to start. This is the particular way we can draw. And this diagram is very important. And labeling is also important at the same time. This is incident ray, and here we have a normal that you have seen at the beginning, and here there is another normal, and here this is refracted ray, and this is emergent ray. Here we have angle of emergence, here we have angle of incidence. So along with that, here there is an additional point. What is that? Angle of deviation. So this angle of deviation is also important, and all of you will try to draw this diagram in your copy and try to label it properly, because the same we will do in the lab also. Okay, same experiment we have. So that's why we have seen. Now it is here in the slide, so you can see in your book also. Okay. Now I will continue.
The angle of deviation is the angle between the original incident ray and the emergent ray. The angle of deviation varies with wavelengths of light. When a beam of sunlight is shown through a prism, the light will split into a spectrum on the underside of the prism. The beam of light will slow down at the boundary between air and glass and will bend. The bending will depend on the wavelength of the rays.
So you understood the point? Bending depends on wavelength. Okay, bending will depend upon wavelength of the light or wavelength of the ray.
Red light with long wavelength will refract less, and then
so this you have to note it down. Red light with long wavelength will refract less, and therefore it will bend less. Note down this point. VIJU, or the last color is red. Why it is red there? Because red light with the red color is with the long wavelength will refract less. What do you mean by refract less? Refract means scatter less. Scattering will take place less amount, so refract less, and therefore it will bend less. Okay, got it? Or we can simply say that the red color deviate least. The red color deviate least, and the reason is its frequency is less and the wavelength is more. Wavelength and frequency are inversely proportional to each other. Okay, see these all points you have to write along with the red light. Which are the points? Red light will deviate least. What is the reason behind that? Red color where the wavelength is maximum and the frequency is minimum. Okay, frequency is minimum, so the speed of light is, speed of that particular color is maximum inside the prism. Maximum speed will be maximum. So this is all related to red color. I think you understood the topic.
will bend less. Violet, which short.
So, and similarly, the other end will be which color? Violet color. So, violet color will deviate maximum. What do you mean by deviate maximum? It refract more. Okay, you can use this term. Violet color deviate maximum. Then what is the reason behind that? Because violet color with a shorter wavelength. Shorter wavelength means wavelength is less. So what does it mean? Wavelength less and frequency more. Okay, wavelength less that means frequency more, because wavelength and frequency are inversely proportional to each other. So violet with a shorter wavelength will refract more and therefore it bend more. So that means violet has minimum speed. Okay, violet has minimum speed. That's why violet color deviate maximum, because it has shorter wavelength. So this is related to refraction through a triangular prism. Okay, let us continue.
Wavelength will refract more and therefore will bend more. This phenomenon of splitting of white light in constituent colors by a prism is called the dispersion of light.
So this is the definition of dispersion of light. The phenomenon of splitting of white light in constituent colors by a prism is called the dispersion of light. Splitting of white light in different colors when it passes through a prism is known under the name dispersion of light. Okay, so this is the basic theory behind rainbow formation. In that case, each and every droplets or droplet of water or raindrops function as a prism. Okay, so that's why we get raindrops in the atmosphere just after the rain. Okay, you can see that at the same time there will be sunlight. Okay, then we get a rainbow. This is the fundamental basic theory behind the rainbow formation. Only the difference is that in the case of rainbow formation, each and every droplet function as a tiny prism. Okay.
Summary. Prism is a triangular optical medium. Light slows down while entering the prism and speeds up while emerging. The bend of the light in a prism will depend on the refraction. White light will disperse into its constituent colors when passed through a prism.
Okay, so then let us think about the next topic. It is also there in the slide. Without that, we can't continue. So let us see that also. Okay. Wait 1 minute. Dispersion of white light by a glass prism. Let us see that.
Have you ever wondered why you see a rainbow in the sky just after a rain? Where do these vibrant colors come from? Well, this can be explained by the phenomenon of dispersion of light. Let's see how we can create this rainbow ourselves. You will require a white light torch, a cardboard with a pinhole, and a glass prism. In a closed room, place the cardboard between the torch and the prism on a table, draw the curtains, and switch off the lights to darken the room. Switch on the torch. A narrow beam of light passes through the hole and falls on the glass prism. Amazing, isn't it? Newton was the first one to realize that a white ray of light, such as sunlight, is composed of different colors. When white light enters the prism, it gets refracted, producing 7 different rays of colors. The angle of refraction is different for each color. Thus, each color bends to a different angle with respect to the incident ray and the colors split up. Separation of a beam of light into its constituent colors is known as dispersion of light, and the band of colors is known as a spectrum.
So the band of colors obtained, it is in the form of spectrum. It is called a spectrum. So we can say that spectrum is the result of dispersion of light. Okay, dispersion of light. It is not in the case of only light. When we go to higher class, there you will see some other prisms also. So for every element, spectrum is there. So it is known under the name atomic spectrum. So two different type of spectrums are there, absorption spectrum and emission spectrum. So this is related to light and it can be applied in case of elements also. So in the case of elements, again spectrum is obtained, but the reasons are little different. But the fundamental reason is this only, separation of light. When it passes through, separation of beam of light takes place when this light is passing through a prism called a Nicol prism. This white light will be continue with another form of light. It is called a plane polarized light. This plane polarized light is used in spectroscope for identifying the spectrum of elements. So this is little bit higher standard. But spectrum is not only for rainbow and not only related to dispersion of light. It is related to elements even. Okay.
Now that you know how light splits up into different colors, let's find out how a rainbow is created. A rainbow is formed in the sky with the help of two things, the sun and water droplets. These water droplets could be in the form of rain, cloud, or mist. Sunlight bends as it enters the droplets in the air. The droplets reflect off the sunlight internally and refract the light again as it moves out into the air. In this way, each water droplet acts as a prism and disperses sunlight. Together, millions of such tiny droplets form the bow-shaped spectrum in the sky. The acronym VIJU is used to remember the sequence of the colors in a white beam of light. From the spectrum, you can see that red color bends the least and violet color bends the most.
So this is one question related to this particular topic. This is a question: why violet deviate most, red deviate least? These are the two questions that you can answer. Okay, so that you can explain on the basis of deviation and on the basis of frequency and wavelength. Okay.
Now, let us go back to our prism and torch setup. What will happen if we place another prism in front of the emerging spectrum?
See the way the prisms are kept. Okay, so when this kind of arrangement will be there, then the emergent ray, look at the emergent ray, it is just similar to that of the incident ray. Because of the reason, which reason? These all 7 different colors will be combined together and it will be emerging out of the second prism. Okay.
Did you see that you got back the original beam of white light? What if you mix these 7 colors together? Do you think you would get white light? The colors of the visible light spectrum, when combined, form white light. Let us prove this by doing a simple activity. Take a paper disc and draw 7 sectors on it. Color each sector.
Maybe this experiment you have seen in some exhibitions. This is called, anybody have seen this experiment in exhibitions?
Yes, ma'am.
It is called a Newton's ring, Newton's disc.
Sequentially with the colors of the visible spectrum. Now, spin the disc. The disc will appear white in color. Remember that the disc just appears to be white. It does not really reflect back white light.
Okay, why it is called a Newton's disc? Because Newton was the first person to suggest the use of the color wheel. Okay, so this is all about dispersion and formation of rainbow. So now I am coming back and stop sharing. So This is all about today's topic. So we'll continue in the next class. I hope